Hey there, Mr. Weaver here, and this is the first lesson of topics 2 and 3. It's one unit combined, and this is our introduction to functions. After this lesson, you need to be able to explain the key characteristics of functions. You need to be able to determine if a representation shows a function, and you need to be able to add an ordered pair to a function to change it into a non-function. After this lesson, you'll know you're successful if you can explain the characteristics of functions, if you can determine if the relation shown is considered a function, and if you can change a function into a non-function. So first, let's focus on that first goal, explaining our key characteristics of what is a function. So, two vocab words that you're going to need to know, and we'll keep referencing them throughout this unit, are relations and functions. A relation is just a set of ordered pairs, or you might know them as coordinate points. Okay, and a relation shows that two values are related. So x is related to y. Compared to a function, which is a little bit more specific, it's a type of relation or rule where each input has exactly one output. So each x value is paired with exactly one y value. And a graph that's a function is going to pass what's called the vertical line test. And that just means that any vertical line that you draw on that graph will pass through only one point. So let's dive into this definition a little bit deeper. The best way I can describe what a function is that it's similar to a vending machine. So here we have a vending machine of some different types of soda. Here you can see we have water here as well, Sprite, Coke, Diet Coke, Dr. Pepper, and so on. If you push a button on this vending machine, you should know what you're going to get. So if I push C5, which is right here, I'm going to get Dr. Pepper. It's not a surprise what I get. If I push C4, I get Dr. Pepper. C6, C7 are both Diet Coke. It's not a surprise what comes out. So you have one input, the button, and you get one thing out, your soda. Now, you can have two inputs that have the same output. Okay, so like C6 and C7 both have Dr. Pepper as their output. That's fine. It's just not two sodas that come out. So I shouldn't push C6 and get either Dr. Pepper or Sprite. I should know what I'm going to get every time. Our next goal for this lesson is to be able to determine if a relation shows a function. We're going to be looking at a couple different ways that you might see it and how you can tell if it's a function. So again, we're going to be looking to see if each input only has one output. So first, let's look at a table. How can we tell if a table shows a function? So I have two tables here. In the first one, I have my inputs, my x values of 1, 5, 9, 13, and 15. I can tell right now that this is a function because each x only goes to one y. 1 only goes to 4. 5 only goes to 2. 9 only goes to 0. 13 only goes to -2. 15 only goes to -3. And those are the only numbers that are part of this table. So that table would show a function. If we look at the bottom table, again, I need to check if the x only goes to one y. So here, x only goes to 1. That's fine. The next one down, I have 4, and it goes to 2. That's fine so far. And then I see 9 goes to 3, but then I have 4 again. So if I pushed that 4 button, the first time I got a 2. If I push the 4 button again, this time I got -2. Are those the same thing? No. So by pushing that 4 button, my 4 input gave me 2 different things as an output. This is not a function. The same thing goes with 9. I used 9 the first time and I got 3 out. I used 9 again and I got -3 out. They are not the same. Okay, so the top one, yes, it's a function because each x only goes to one value of y. The second one is not a function because we have 4 that goes to 2 things and 9 goes to 3 and -3. They are 2 different outputs for the same input. That's not okay. Now it's your turn. Pause the video and see if you can determine if each of these tables shows a function or not. All right, hopefully you paused the video. Here are the explanations for your tables. Pause the video and read through why each is a function or not. Now let's look at a list or just some coordinates written out. This one's a little trickier to tell because the numbers are close together and it almost looks random, but we're going to follow the same pattern that we did with a table. If it helps you, write your coordinates as a table. When we're checking a list, we just need to see if each x goes to only one y. So a quick way to go through these is to check the x's. If the x's are all different, that means it can't go to 2 different things. If you see a repeated value of x, then check to see if they go to the same thing. If they do, you're good. If they don't, no. Okay, so in my first list, I have -6, -5, -2, +2, 3, and 0. Those were my x coordinates. I didn't repeat any of them. They're all different, which means they can't go to 2 different things. So that top one must be a function. In the second example, -5, -2, -1, 0, 2, -1. I already used a -1, and now I have it again. The first time it went to -3, the second time it went to +6. Did it go to the same thing both times? It did not. So the first one's a function because each x only goes to one y. The second one is not because the input of -1 went to -3 and 6. Now it's your turn. Pause the video and see if you can see if these 2 lists are functions or not. Here's your explanation. Pause the video again and read through to check to see if you did it correctly. The next one's called a function map. This shows a group of inputs on the left, and it shows what they go to as outputs on the right. The arrow shows what number came out. So if I put 1 in, 4 came out. If I put 2 in, 4 came out. 5 went in, 5 came out, and so on. For a function map, you're just needing to check if a number goes to more than one thing. So in this first one here, 1 only goes to 4, 2 only goes to 4, 5 only goes to 5, 7 only goes to 20, 8 only goes to 20. That's fine. Okay? Each number on the left only went to one thing on the right. If I look at the second one, 12 only goes to 3. That's good. 19 goes to 6, and 19 goes to 12. That right there tells us that the second one is not a function. Okay, so the left one is a function because every input on the left points to only one output on the right. And then the right one was not a function because 19 goes to 6 and 12. Now it's your turn again. Pause the video and determine if these function maps show a function or not. Here are your answers. Read through and determine if you did it correctly. The last type of relation that we need to determine are graphs. So there are two types of graphs that you're going to see. So you might see discrete graphs where it's just some points, or you might see some continuous graphs where there's actually a line drawn. When we have graphs, we're just thinking along the same lines. Does each x only go to one y? So if we're looking at coordinates, in this first graph here, my x value of -3, which on my graph would be 3 to the left, only goes to that 1 point, to +4. -1 only goes to 4. 0, left and right, only goes to 1 up. 2 to the right, +2, only goes to 1 down, -1. Okay, this first one is a function. Each x, left and right, only goes to one y value up and down. If we look at the second one, 3 to the left pairs with 4 up, so -3, 4. We have -2, -1, that's the only -2. 0 goes with 4, that's the only 0. But when I get over to +2, it goes with 3 and it goes with 6. So plugging in -2 for my x gave me 3 and 6. If you see 2 points where one is directly above another, that tells you that it's not a function. Okay, so the first one's a function again because each x only has one dot, so it only had one output. On the second one, there are 2 dots on x equals 2, which means it went to more than one y value. It's not a function. Pause the video and check your 2 graphs. Are they functions or not? All right, check your answers. Another way that you can quickly determine if graphs are functions or not is called the vertical line test. So the vertical line test says if you draw a vertical line through every point, it should only pass through one point. So that first one, I drew a vertical line straight up and down, and it only goes through one point. It's a function. Okay? Each vertical line only goes through once. If I check the second one, 4 of the lines only went through one point. So the 4 that are there are good. However, this line goes through 2 different coordinates, 2 points. It is not a function. Okay, a vertical line went through more than one point. So if I check the 2 that you just did, the first one, all 5 lines only went through one point. So it was a function. And the second one had that one instance where the line would have went through 2 points. It is not a function. What about continuous graphs, where it's showing a line or a curve as your graph? Well, let's just use our vertical line test. So if I drew a bunch of vertical lines, I just need to check, does it go through the graph only once, meaning it's only going through one point. On the left, each vertical line only goes through the graph once. It only went through one point at a time. Yes, that is a function. What about the one on the right? Well, if I drew a vertical line right at the very left edge, it would go through one point. But every other time that I drew a line, it would go through twice. It would cross that graph in 2 different places. So the first one would be a function. The second one would not be. There are many, many places where it crosses in more than one spot. Pause the video and try your 2 graphs using now the vertical line test. Hopefully your vertical line tests look something like this and your explanation is similar. Check to make sure you did it correctly. Now let's move on to our third goal for the day. So adding an ordered pair to a function so that we can change it into a non-function. So how can we make a function into a non-function? So let's start with what is the definition of a function again. So every input has exactly one output. In many of the examples that we just did are non-functions where times where our input has more than one different output. So if we want to change a function into a non-function, we need to take it from where each input has exactly one output and then make it so that an input now has more than one different output. So let's start with our coordinates. So the way it is currently is a function. Our x values are -6, -5, -2, 2, 3, and 0. They're all different. It's a function. If we want to make it into a non-function, we just need to choose an x value that's already there and then make it go to a different y value than it was before. So let's say 3. I just picked a random point. I'm going to use 3 as my input, and it already went to 7. So I just need to make it go to something different than 7. So 4. Now my input of 3 goes to 2 different outputs. It's no longer a function. Let's look at a function map. So currently it's a function. Each one on the left goes to one thing on the right. So again, I just need to make my input go to more than one output. So choose again something you already used. Make it go to something different than before. So let's say I chose 5. Right now it goes to 5. I want to make it go to something else as well. So let's make it go to 4. I would just draw an arrow to 4. Now that shows me that 5 went to 5 and 5 went to 4. It went to more than one thing. It's no good. No longer a function. What about a table? So just like the coordinates, choose something we've already done. So let's say we pick 5 again. Our output needs to be something that's different than what it was before. So it was 2. We can pick something different. 3. There we go. So now 5 goes to 2 and 5 goes to 3. It's no longer a function. And finally, we have a graph. So for graphs, all you need to do is make it so it no longer passes the vertical line test. So one dot is directly above another. The line would pass through two things. Okay, right now it passes the vertical line test. Let's make a point directly above one that's already existing. So that one would no longer pass, and then we no longer have a function. And that's all there is to changing a function into a non-function. So in this lesson, we learned a couple different things. So first, a function is a relation where each input only has one output, like a vending machine. You can determine if a relation shows a function by looking for matching x values and seeing if each x only goes to one y. If you have the same x and it goes to different y's, it's not a function. Using this to change a function into a non-function, we just focus on what makes a function a function. The fact that each x goes to one y. So, if we don't want it to be a function anymore, use something that's already there for x and make it go to a different y value, and it's no longer a function. So after this lesson, do you now know how to explain the characteristics of a function? Can you determine if a given relation shows a function or not? And can you change a function into a non-function? If you're not sure on any of these things, find the learning target in the lesson and go back and rewatch that part. And that's the end of lesson 1 on our introduction to functions.